Hello everyone. In the last video, we looked at RDF in depth. And at the end, basically, I said, hey, I like working with network X. So in the next video, meaning this video, we are going to look at some, an application. And here we are, right? So here we are learning about a learning path recommender. And for this, we are going to use manual construction of knowledge graphs. So the whole point here is we are going to define certain nodes and edges, and the application here is basically learning path, right? So we need to understand the learning path, and obviously, as you know me, our learning path here is going to be learning about Python. And as you can see on the screen, different aspects are in different colors because we chose to print it that way. And the ones in the orange, it's a path for cell biology basics. The green path is for financial analysis, and the other one is just basics of Python, for example. And we constructed this in a manual way. What do I mean by manual? You are defining the node, you're defining the attributes that goes along with the nodes, and you're defining the edges and attributes, like what is connected to what, and you're defining it as an expert. This is quite common when you're doing, for example, something like this, or product development, for example. Hey, what are the important features in your product, for example, right? So there you can say, hey, these are the features and these are the central features, and you want to find out what the centrality is, what is the betweenness centrality is, what is a different type of centrality is. So that is something you need, where you define things manually. Now you're wondering, what do you mean by manual? How else would you define a graph? Well, in the next tutorial, that's why hit the pause button right now. So and hit the subscribe button that you see down below. And while you're there, also, if you're feeling generous, hit the thanks button. Now, coming back to the topic, why did I say subscribe? Because if you want to be notified of the next video where we actually build a graph that's not as simple, much more complicated, because there we are going to load all the 400 plus videos that I have on my YouTube channel, along with the titles, along with the description, and then we run a natural language processing, because to connect each of these nodes of, like, let's say 400 nodes, right, 400 videos, to connect them in a logical way, it takes a lot of your effort and time, and you may not even, it's probably not even practical in some scenarios. So we are going to use natural language processing to extract the semantic meaning from some of these and assign that to these nodes and edges and try to connect them in an automated way. I bet you find that to be exciting, interesting. So again, please stay tuned for that. Now, for this exercise, let's go ahead and look at the basics of how to construct your somewhat not simple, trivial one like the last couple of videos, but somewhat meaningful knowledge graph, and then run some queries on it and build a basic, let's say, recommender engine. I say recommender engine. Basically, when you say, hey, I want to learn this, then it goes back and checks what the prerequisites are to get to that state, and then it actually creates those based on how far that other nodes are from a given node. This is what a recommender engine is at this point, right? Okay, so with that information, I think we should go ahead and jump into the code. I don't want to waste your time. Well, let me change that. There are different ways of learning. One is going through PowerPoint presentation. The other is directly jumping into code. Last video, we explored the PowerPoint presentation because we needed to learn a lot about the basics. But now we just jump into the code, and I added a lot of notes as part of the code. Thanks to, I guess I used ChatGPT or Claude. I'm like, hey, here's my code. Just add some notes, and it gave some notes, and I kind of edited it to make sure it makes sense. Otherwise, it gives a lot of garbage. Okay, I am talking a lot of garbage right now. Let's jump into the code and pick up right there. Okay, so first thing first, of course, this is Google Colab. Let's go ahead and connect it. And the link to this code is going to be in the description down below. So please go ahead and look for it down there. So I added a lot of text here because I wasn't going through, I haven't, done a PowerPoint presentation on this, what exactly is going on. But more importantly, the description fits better within this context anyway. I mean, within the code anyway. along with the code, I should say. I'm looking for words today. I need my coffee break before recording the next video. So this code is basically, it's demonstrating the construction of our knowledge graph videos from DigitalSreeni's YouTube channel. I'm not taking like the entire, all the videos in this case, because that's not very practical. But I'm going to break it down into different topics. So basically, I broke it down into core Python programming concepts, financial analysis, like you saw in the graph on the my main slide, and bioimage analysis and microscopy. So these are the three main paths for someone, let's say, potentially. And each topic I carefully annotated with metadata, including what is the difficulty level for a given topic, what are the keywords and domain classification and details. We'll see those in a minute. And the relationships are manually weighted. I say, okay, a prerequisite strength can be 1.0, it can be 0.8 or 0.5. So the weight itself kind of describes the prerequisite, but the weight can be anything, right? So the weight can mean anything. In this case, in my mind, when I was defining the weights, I had prerequisite as the strength for this weight. Okay, now content similarity and learning path progression. Okay, so the resulting graph, we are going to look at the graphs using both PyViz and Matplotlib. In fact, I should just comment out everything Matplotlib, because you'll see PyViz makes more sense because it gives you interactive plots. Okay, I also added a note about, okay, this manual approach, great. It gives you expert curated learning paths, right? This is always great if you can do it. If you have like a team, sitting and coming up with these plans, then you have like people working together trying to define these. That's great, but oftentimes, like I mentioned, if you have thousands of these nodes, then it's not practical to do things in a manual way. You need an AI-assisted approach, which is exactly what we're going to do in the next tutorial. But first, let's look at the basics here. Okay, so let's go ahead and install PyViz and network. I was experimenting with this other thing. I commented that out. I don't think I have any code left that uses the third library given here. Okay, so both PyViz and NetworkX should be installed in a matter of seconds. And we are going to import NetworkX to define, obviously, our graphs, and PyViz for plotting. And again, we are importing this network method from PyViz, and this network method can be used to add nodes or edges or anything, as part of your plotting, not to define a graph, but as part of the plotting itself. Okay, so everything else hopefully makes sense when we get to that part. These are all standard libraries. I also imported SQLite 3. I'm not sure if I'm using it in this or the next tutorial, but that's there to show you, to demonstrate how you can serialize a NetworkX graph and save it into a SQL database. But let's focus more on that in the next video. Let's understand the key core basics right here. Okay, so you create a graph by adding your nodes and edges. Obviously, that's the part you know. And the step one here is I'm defining Python topics. These are the nodes that I'm defining. Okay, so topic is basically the nodes, and then we'll do the edges, which is we'll get to that in a second. So what topics do we have? So I'm adding topics of Python basics and data type variables and control flow and so on. And what is the difficulty level of Python basics? It's a beginner. And what are the keywords that defines the Python basics? This is a programming, syntax, basics. So why am I defining this? Because later on, when I try to create certain clusters of, okay, show me all the beginners where, we cover certain topics, then we can use any of these attributes to kind of extract the nodes corresponding to these attributes, right? And of course, in this case, the domain is programming. So I added that, and description is, this is basic Python programming concepts. And similarly, let's just jump to something else that says, okay, error handling, right? So error handling is not something that you do in the basics. It's an intermediate difficulty. Keywords is, okay, obviously, when you do error handling, you have exceptions, errors, debugging. These are all part of your error handling. So these are the keywords I'm assigning to that specific topic or a node. And the domain, of course, is still programming and object-oriented basics and advanced object-oriented. So let's stop there. You can add so many other nodes. Now let's switch to finance topics. Very similar. Okay, economics 101. If you want to do financial analysis, it obviously makes sense for you to know economics 101, like the basics. So markets, for example, what is stock and that type of stuff. And the domain here, I defined it as finance, and then the stock market basics if you want to do, the time series forecasting and that type of stuff. And there you go, trading and markets and stock market fundamentals. And I added a few of these. Eventually, what's your goal? To hopefully, probably performing algorithmic trading, which is of course an advanced topic. And here the keywords are different, and domain of course is still finance. And then switching the topic to bioimage topics. This is someone else, right? So who is interested in bioimage analysis? The domain is biology. And of course, again, it makes sense to start with cell biology basics. You need to know what cells are. You need to know what, for example, neurons are. If you're a neuroscientist, then in this case, this is a beginner, and you need to go to intermediate, which means you need to understand image analysis basics. You need to know what edge detection is before you can apply that in Python. You need to understand what's happening. Otherwise, you can just pull whatever function and then apply, and you're like, okay, can't leave it to chance for it to work. And of course, you need to understand Python imaging, and then going to advanced bioimage analysis, where you start to apply all of these into running one complete automated assay, like a cell painting assay, where you have all the information coming in, and you have machine learning to extract to perform your phenotype typing, for example. Okay, so biologists, hopefully you relate to that last 1 minute. So these are edges that we are defining here. Again, there may be many other paths, right? So defining relationships. Now we define a relationship by actually, in this case, when I call the relationships, it's returning a list of all these tuples, and each tuple defines a specific relationship. So for the Python core path, we have Python basics connected to data types, and then with a weight of 1.0, right? So this is a strong prerequisite. You need to know the basics before you need to learn something. Let's look at object-oriented basics. I think even here, it's a strong requirement if you want to know advanced object-oriented, you need to know the basics. But I just put some random number right there. Okay, so same with finance path. I defined certain finance paths right here, and then bioimage path. This is just a definition of dictionaries and list of tuples. That's pretty much it. Now we need to unwrap the dictionary, unwrap this list of tuples to actually create a graph. That's exactly the next step. We are building a graph right here. You can, in fact, I really advise you to add one node at a time, at which point you just do, define that and add Python imaging, add node Python underscore imaging, and then keep adding nodes and keep adding the edges. That's one way of doing that. Here we are just defining the dictionaries, so we can just unwrap them and automatically create these nodes and then connect them with edges. Of course, in our case, this is going to be a directed graph, because you go from Python basics to the advanced Python, but not the other way around, right? So although someone like me, I always go back to basics to understand, okay, how I totally forget. My weakness, just so you know, is lambda functions, right? I know they're so freaking strong at doing something powerful, but I never figure out what is the right way of doing it. That's my weakness. That's it. Everyone has their own weaknesses. That is my absolute weakness. I have no clue why. I'm more comfortable doing a nice long for loop than actually doing a lambda function. So if you guys know a trick, if I'm missing that one, little thing that's stopping me from getting to the aha, this is how it's working, let me know. Okay, again, I should stop going on this side tracks, but let's get back. We are building a graph. This is a directed graph. And again, we are going from one direction to the other. Okay, so far so good. Now we need to get the dictionaries and then unwrap these dictionaries, and then in the for loop, we are going to add them as nodes. So first thing, when we create a topic dictionaries, we have 3 elements in there, right? So we have Python topics, we have finance topics, and we have bioimage topics. We have these 3. So let's get each of these separate topics. And for all of these topics, of course, I'm unwrapping each of these dictionaries and then assigning that to all topics. Now we are going through all topics.items, individual items within each of these topics. And we have two things that we are unwrapping, right? So for each topic, we have topic ID and metadata. If you look at the dictionary, sorry, we should go back. If you look at the dictionary, you have the topic, and within that topic, you have the metadata. So I'm unwrapping this as the topic and this entire thing within these brackets as the metadata. That's let's go back here. So for topic ID and metadata, go ahead and add a node with the topic ID and unwrapping the metadata. Go ahead and add that as metadata. So basically at the end of it, you get a node with the metadata as attributes. That's it. Again, you can add this individually. Basically type g.add_node. I mean, once you define your graph, and then whatever the Python basics or something, and then add the metadata individually, right? So what is the difficulty? What is weight, and so on. That way you get a better idea if this is the first time you're doing this. Okay, and then we need to define the edges or relationships between these nodes, and that is very similar way. We are unwrapping the relationships. We have from topic, to topic, and weight, right? I mean, that's, I think, how we define from topic, to topic, and what the weight is. And basically add that. Graph.add edge, go from topic to topic, and add the weight. And in our case, we are just going to call this prerequisite, right? So this is the type, is prerequisite. That means from is a prerequisite of the to. Why is that important? Later on, when we do our Python path analysis, learning path analysis, sorry, not Python learning path analysis, this becomes important because when we say, hey, show me all the prerequisites, it's like, okay, what is connected to at the first level, at the second level, and third level, and so on, and we can print those out. Okay. Building the graph is basically now you have the graph and topic metadata, and we are just going to build the graph. Right? So when you build the graph, what is it returning? Basically the graph and the all topics. That's what we are returning when we build the graph, right? Graph and topic metadata. Okay, good. So when we run this, we get our graph. Sure. Next, visualization. So graph building hopefully makes sense. The next steps are visualization and performing analysis or querying. That's what we are going to look in the next part. Let's do visualization using PyVis, which is basically the input is going to be a graph. In our case, it's a directed graph, right? That's our input. So basically this graph that we just built is going to be the input, and then the metadata, which is nothing but a dictionary, is going to be another input, and output file is the PyVis is nothing but it's going to generate a plot in an HTML format. So I'm going to export this as HTML. Unfortunately, within our Colab environment, I cannot get this. At least I couldn't figure out how to get the embedded HTML like interactive plot. So I'm going to save HTML and then open, and we're going to collectively look at the visualization. And the next part is basically I'm defining network. Remember, we imported this network from our PyVis library. PyVis.network is what we are importing, and I'm defining that as a net, which is again, is this notebook true, and what is the height and width and background color that I would like to use, and this is a directed equals to true, yeah, directed graph. Okay, color map, I am choosing, all of these are advanced, you don't need to do any of this, you can just type net equals to network, and then you can just add your nodes and all that stuff. So here, add the graph. What I'm doing here is assigning these light blue, light green, and salmon colors that you saw on my original screenshot. And this is what we are going to assign to different themes in our learning path. So for each of these nodes in our graph.nodes, our metadata equals to whatever we are extracting the metadata, and then we are going to the network that we defined here. To the for visualization, we're going to add the nodes. So basically here we are going to add separate nodes, and then the edges right there is what we are adding. And again, you can try these PyVis one at a time, one node at a time, one edge at a time. Once I define this function, I just keep loading it. That's it. So this is a function that helps me visualize my graphs later on, basically. Yeah. Okay, and I also have a function for visualizing using matplotlib in case you want to compare. I use it just once, I believe, and then just so we have it in our documentation if I need it for later. So that's pretty much it. So that's why I have this, and I think we should start running them rather than just jumping through all the topics. So let's go back. Let's go back. I should have done that. So we did the first one. Let's go ahead and run this second. Defining, this is just defining your dictionaries right there. And the edges right here, the list of tuples. Now let's go ahead and build the graph. This actually should build our graph because we are building it right there. And now let's go ahead and run the visualization part of the code. And let's go ahead. I mean, that's just the functions. Now let's go ahead and visualize it. So both ways. Let's first look at the matplotlib, and then PyViz should be stored right on the left-hand side. If I see learningpaths.html, let me go ahead and download it so we can check it out in a second. Let me close that part. Okay, so visualization. So here is the visualization of our learning path. This is why I'm not a big fan of doing things in using the default NetworkX plotting. This is basically, I say pyplot, but basically we are using nx.draw. NetworkX's built-in functions that actually, for plotting, that actually uses pyplot in the backend. But this is what you would see. For small graphs, this kind of makes sense, but for complicated, even this is not that complicated, right? So for these, you're like, okay, what is this connected to? Advanced bioimaging, why is it all the way over there? It's a bit confusing. So let's go ahead and open the HTML that we just downloaded. There you go. Isn't this much better visualization wise? Yeah, so I can kind of move this. This is fun. It's always fun to move things around and see what's going on. In this case, there is not much overlap going on, but you see how neatly it connected this node to here, and it connected the node to right there. So I can kind of clearly see what's happening over there. So I personally like this visualization, but again, as you can see, Python basics is right there. If you look at degree centrality, which we'll do later on, basics should come somewhere here. Python finance, if you're in that path, this is one of those nodes right there, and data structures is right here. So we'll do analysis in a minute, but these are different paths. Okay, and by the way, for example, biology path, it's not like you're starting at Python basics. Python comes later. You start with cell biology basics. This is non-Python stuff. These are all the basics that you kind of need to know, and then comes the basics part and all that. Maybe this is how I defined, right? So this is just showing me what I defined. Let's go back and start performing analysis. So let's go ahead and do basic analysis right here. There's a lot of text, and I need to wear my glasses occasionally. Okay, so what basic analysis can you perform? There's so much you can actually perform here. The first thing I'm doing is nx.pageRank. You see how I'm directly importing these methods from our NetworkX library. So they have something called PageRank. PageRank basically, I believe it means how many incoming connections are there, to a given node. I may be wrong. I should have written down what exactly it is, but that's my understanding. And then you also have, for example, in degree centrality and betweenness centrality. There are various centralities. Obviously, centrality means how central is a given node in your graph, but then what does centrality mean? Like, what do you mean by central? There are many ways, and for example, betweenness centrality down there, it indicates how often a node lies on the shortest path between other nodes in the network. What does that tell you? Well, it measures the role of a node as a bridge between different parts of the network. So these can be very important, right? So, hey, this is a good bridge between these. It's very important. If it breaks, then parts of your system will break, and that's that. And in degree centrality, I believe simply, the one that you see over there, it simply counts the number of incoming connections to a specific node. So that's what in degree centrality is. So you can print like various other basic, you can perform other types of basic analysis, but let's go ahead and define this function right there, and let's go ahead and run that analysis, and let's go ahead and print all that stuff. So basically, PageRank of nodes. So for algorithmic trading 0.09, which one has the highest PageRank? Let's go ahead and see. I think this is the one. It's actually ordered in terms of page rank right there. So let's go back and check algorithmic trading, 0.09. Algorithmic trading. Where do I see algorithmic trading? Finance right here. Finance, technical. Am I missing something here? Oh, right there, algorithmic trading. So it's actually one incoming and then other incoming all to this Python finance. So, and which one has the least? 0.01, right? So cell biology basics has the least. So you always have to go back and see. So there is like absolutely no incoming connections right there. And economics 101 should also probably be one of the lowest ones if I can. Yeah, economics 101 also has the same value when it comes to the page rank. Okay, now in degree centrality that are important prerequisites, for example, if you look at Python finance, it's 0.1818. So if you look at Python finance, again, where is Python finance? Python finance, yeah, right there. Obviously, you can see a lot of things are pointing to it, right? So that a lot of incoming connections right there, which is what the in degree centrality is all about. So Python finance gets the most. And betweenness centrality, data structures has 0.06 data structures. Let's go here and check out our data structures. Betweenness centrality. So this is, again, acting as a bridge between multiple topics, basically. So for Python finance and also for Python basics, you see right there, Python imaging, the data structures is a bridge to go to these two. So no wonder it's got higher rank right there. So again, we start off slow with some basics over there. And now let's go ahead and get prerequisites. Prerequisites is all about, hey, what's before this, what's before that, right? So that's prerequisites. And we are going through the graph and we are looking for prerequisites. I just opened a empty dictionary right there so we can go ahead and populate it. And you can also look at the depth, right? So what is the depth you want to look at? So is it like one node before, or is it like 2 or 3 nodes before, and so on? You can define that. I think, did I add that as an input? Yeah, max depth equals to 3. You can change that. So up to 3 depth. Go ahead and give me the prerequisites. So while you're within that depth, go ahead and look at graph.predecessors. Yeah, that's it. It's very simple when you're using NetworkX in terms of getting your analysis done. So that's why I prefer this library quite, much better over other approaches. Let me put it that way. I'm more comfortable using this approach. Probably that's what it comes down to. So basically we are just going, this is the meat of it, graph.predecessors, and that's the meat of it. And that's basically, what we are running right there. And this part is just go ahead and print the prerequisites analysis. And for that, we need to define, okay, these two are functions anyway. Let's go ahead and run them and let's execute it down here. So analyze prerequisites. Prerequisites to what? Let's put algorithmic trading, right? So let's actually put algorithmic, I need my glasses. Let's put algorithmic trading right there. So if I want to get here, what are the prerequisites, right? So the immediate prerequisite is Python finance, and then it can be financial analysis basics and technical analysis, right? So these two should come up with similar weights, and then the next level is right there. So let's see what it actually prints out. And okay, so level 1 prerequisites are Python finance. That's it. There is only one prerequisite at level 1, Python finance. We obviously know that. At level 2, you have 2 of these. Hopefully, it should print out those 2. At level 2, you have Python basics, financial analysis basics, data structures, technical analysis. I forgot that from here, these 2 are also. I was only looking at the green path, but when you look at this other path, data structures and Python basics are also prerequisites, as you can see. And of course, level 3 prerequisites, you go one level further deep, and that's what we're printing down there. Once you build the graph, everything is so simple, as you can see. Now, you probably tuned into this video because it's a recommender system, and this is basically, hey, recommend the learning path. You need a graph as an input, of course. And in this case, because I only have like 2 domains like finance and bioimage, I'm like, okay, throw in message if it's not one of those. And if it is finance, go ahead and look at the target node as algorithmic trading. This code is highly customized for our specific use case, because when you are going through finance, the algorithmic trading is the end result. Hey, this is, if I achieve that, that's my goal, right? So we need to define a learning path to get to that spot. Basically, that's what I'm trying to say. And if it is biology, then of course advanced bioimage analysis is the last path, which is right there, advanced bioimage analysis. So how do I get there? Now, all we are trying to do is look at all shortest paths right there. Okay, and if there is no path, of course there is no path, but we are looking at all shortest paths, and of all of those, the first one that is going to be reported is going to be the optimal path, let's say, because the path, we are taking the first shortest path, but you can also print the second shortest path and so on, but this is the first one. And the rest of it is basically, we are just printing it out and printing all the details, basically the estimated complexity and prerequisites, because we do have the complexity associated with our metadata, and that's something we are printing right there. And of course, prerequisites is something we can also print. And but the meat of this entire thing comes down to basically the shortest paths, right? And by the way, I also added something called additional recommendations, because yeah, we are taking the shortest path, but if it's not part of it, or if it's not advanced, basically go ahead and print it out. The remaining topics that are not addressed here. Basically, I want to say, hey, this is your learning path, but you may also want to consider these supplementary topics, because if you take the shortest path, some of the other topics may be overlooked. That's my justification right there. So go ahead and run that. And now we are going to check this for a couple of things. Let's check the recommended learning path for finance and also for bioimage. And let's end this video on that note. So, okay, so recommended learning sequence. First, start with Python basics for Python in finance, obviously. Python basics. And then go into Python finance, right? I mean Python basics. Let's see. So there you go, Python basics, okay? And then Python finance right there, right? Because you need to get to algorithmic trading, and then algorithmic trading. Maybe I should have done a better job in defining this algorithmic trading. Maybe it shouldn't be just right next to Python finance. Maybe after a few of these. Okay, so that's where this is. And then because we overlook certain topics, it's like, hey, supplementary topics you might find useful is economics 101, stock market, financial statement, technical financial, all of this stuff that got ignored basically because they're all connecting, you see, to the Python finance. So we need to, why not include that? That's the whole point of this second part right down there, okay? Let's look at the result that we got for bioimage analysis. Hey, start with Python basics, Python imaging, advanced bioimage. Python basics, Python imaging, and advanced bioimage analysis. That's a short path, and these are the other topics you may want to consider. Basically down here, cell biology basics, microscopy, supplementary topics you might find useful. So I hope you found this to be useful. I mean, there is no programming skills that we are displaying here, because the people, the team that developed Network X did everything, to make life easy for us. All we need to think about is, okay, if I am actually looking at the shortest path, right? So that gives me, what the answer is. So you need to figure out which tools from Network X library are relevant to answer your question. And then it's a matter of printing after that. What else do you want to print in addition to, from that result? That's it. Okay, so I seriously hope you learned something, from this video. Hopefully you will join me in the next one where we do something similar, except we are going to take it to the next level. We are going to use natural language processing to extract information directly, from the text, rather than us defining dictionaries for our nodes and edges. So hoping to see you there, and thank you very much. And again, do not forget to hit the subscribe button.